Okay, so a little reminder then from we're going to finish lesson 4. So back here when we were first started out, when we were talking about inverse trig functions, that we mentioned that here we had, if we know the angle, we can do sine, cosine, and tangent of that angle, and it'll give us a ratio. Well, what we're going to look at more so today is that, okay, if I'm given the ratio and I want to find the angle, then I need to do inverse sine, cosine, or tangent. So the one note you should make is the fact that if I know the angle, I'll use sine, cosine, or tangent. If I'm trying to find the angle, then I want to use the inverse. Okay? So if we know the angle, we use sine, cosine, tangent. If we're trying to find the angle, we're going to use the inverse. Excuse me. So here a painter needs to lean a 30-foot ladder against a wall. Safety guidelines recommend that the distance between the base of the ladder and the wall should be 1/4 of the length of the ladder. To the nearest degree, what acute angle should the ladder make with the ground? Now, a really important thing is when you have a story problem, you can draw a picture, you need to draw the picture. So basically, all we need to draw is a picture of a triangle. Okay? You know, if you want to get more technical with it, you can. Here's our wall here, and here's our ladder here. That's a pretty good ladder for me. Right? And now I have a right angle, a right triangle. And it says the painter needs to lean a 30-foot ladder, so that's quite a long ladder, against the wall. And the base of the ladder should be 1/4 of the length of the ladder. So this side right here, x, is 1/4 the length of the ladder. So what's 1/4 of 30? 7.5. Okay. So the ladder is 7.5 feet from the wall. And they want to know what is this angle here, theta. So since we're trying to find the angle, that means that we're either going to use inverse sine, inverse cosine, or inverse tangent. The first thing I need to know is which one of those three am I using? Okay? So here's the angle. I know a side that's 7.5, and I have a side of this triangle that's 30 feet. So the 7.5 side, which part of the triangle is that? Okay, that's the adjacent side. All right, and the 30 feet ladder is what? The hypotenuse. Okay, so which one of the three trig functions is adjacent and hypotenuse? Cosine. Okay, so we will say that the cosine of theta is equal to the adjacent over the hypotenuse. And so if I'm trying to find the angle then, theta, I will do the inverse cosine of that fraction. And they want us to find our answer to the nearest degree. So we'll take our calculator. Just quick check, am I in degree mode? Yes, I am. Good, makes it much easier that way. And then we do second cosine. So we have inverse cosine. 7.5 divided by 30. And when you're doing these, you can just use the fractions. You don't have to change it to a decimal to use it. Most of the time when I do it, I just leave my fraction that way. That way I have exact numbers I'm always using. So we get 75.52. So we would say approximately 76 degrees is the theta. So this is a case where I know the ratio, try and find the angle, so I do the inverse. Okay, let's do the last example. Now this problem gets a little bit harder. Okay, the first part of them, the first example A isn't so bad. Excuse me. Example B gets a little bit tougher for people. And before we go start doing it, I want to talk about reference angles, because we're going to use reference angles to help us in these problems. So if I draw a coordinate axis, first of all, let's talk about what is a reference angle. Do you remember what a reference angle is? Okay. How far the angle is from the x-axis. Okay. So that means then if it's in the first quadrant, we're talking about this angle here. Okay, that would be the reference angle. If we're talking about an angle in the second quadrant, then we're talking about this angle here. Okay, the distance the line is, or the angle is, from the x-axis. So if I was in the third quadrant, it would be down here, and in the fourth quadrant, it would be here. Okay, it all references back to the x-axis. Now, the one thing is I want to talk about how would I find this angle here? So if I knew theta, how would I find that blue angle? What would I do? And we'll work with degrees right now. So here's 180 degrees. How would I find that blue angle if I knew what theta was? And it's the same in all four quadrants in this case. How could I find it? Subtract it from 180, okay? So if I'm in the second quadrant, I will subtract that reference angle from 180 degrees, okay? Well, what if I was in the third quadrant? What would I do? Now look at where it's at, okay? The angle is here, right? All right, it goes from the x-axis to this line here. So I'm not theta short of 270. I went 180 and then went theta, right? So this is 180 plus theta, okay, if I'm in the third quadrant, right? So in the second quadrant, I came that reference angle short of 180. In the third quadrant, I go that much past 180. Okay? And what about in the fourth quadrant? What would it be in the fourth quadrant then? So in the fourth quadrant, we're going all the way to here. Okay? So it would be 360 subtract theta. Okay? So let me redraw that. Draw my butterfly. Okay? So in the first quadrant, it's just the angle. In the second quadrant, it's 180 minus the angle. Third quadrant, 180 plus by reference angle. And in the fourth quadrant, you actually could do two things, because it kind of depends what they're asking for. Most of the time, it would probably be 360 minus, but you could also just do the negative of the angle. Okay? Depending on what their restrictions are they're looking for. If they say I'm from 0 to 360, then yeah, I would do 360 minus. But like in this case here, they say between negative 90 and 90, so I could just use the negative angle if I was in in that situation. Okay, so goodness. Letter A here. Now this is also important that you know where sine, cosine, and tangent are positive and negative. Okay, and so we wrote that down. Okay, they're positive in this quadrant, negative in this quadrant, and so on. So this says sine of theta equals 0.4. And we want to find theta between 0 and 9, or between negative 90 and 90 degrees. So let's take our calculator and do the inverse sine of 0.4. And when this number here is positive, this 0.4 is positive, it's going to give you the reference angle that I want to work with. So this is going to tell me what theta is. So what'd you get? Inverse sine 0.4, 23.57, and this says to the nearest tenth, so this is approximately 23.6 degrees, right? Okay. Now, I wanted to talk about the reality of that for a minute, okay? Does that make sense? Okay. Sine is y, correct? So my y value is 0.4. If I was to look at the unit circle, where it's at back here, there we go. If I look at the unit circle and I have a y value of 0.4, that means it's going to come to about here, right? My y value is going to be about 0.4 because sine of 30 degrees is 0.5, 1/2. So if I only had 0.4, that means the angle here better be less than 30 degrees. Okay, that makes sense, right? Okay. Okay. So now, this is a reference angle I have of 23.6. So this angle here is 23.6 degrees. So if I needed to go into the second quadrant, or the third quadrant, or the fourth quadrant, then I could use that 23.6 and either subtract from 180 in the second, add to 180 in the third, subtract from 360 in the fourth. Okay. So letter B here says find the sine of theta equals to 0.4, but between 90 and 270. So now we're going to be we're talking about over here on the left-hand side of the graph is between 90 and 270. And it says that sine is positive 0.4. Well, where is sine positive then between 90 and 270? Is it in the second quadrant or the third quadrant is sine positive? Well, sine is y, right? Okay, is y positive in the second quadrant or the third quadrant? The second quadrant. So what do I do with that reference angle then in the second quadrant? We subtract it from 180. So theta here then is going to be 180 minus 23.6. And so that is 156.4. Okay. Now, take your calculator and do the sine of 156.4. Because I want to verify that that answer is correct. Okay. Really close to 0.4. Okay, so I can make sure I have the correct answer then. Okay, but think about how that reference angle works though. If I say that this y value here is 0.4. Okay, I don't know what the x value is, but the y value here is 0.4. Well, that means then that the y value over here is 0.4. All right, so that this number here, I should say, is 0.4. And in the denominator, it would be, or in the denominator, in the bottom half, it would be negative 0.4 down there. So if they ask me to find the sine of theta equals negative 0.4, then I can still use that 23.6 degree reference angle, but I would just be adding it to 180 and subtracting from 360 for the third and fourth quadrants. Okay. So if they change this and they said, okay, I want to know when the sine of theta equals negative 0.4, well, what I would do then is I would find the reference angle in the first quadrant. So that means I would do the inverse sine of positive 0.4 and then go to the quadrants where sine is negative and do the things I need to do with that reference angle to find those specific angles. Okay. Yes. Yep. We're going to do the absolute value because that'll always give us the reference angle in the first quadrant. And then I can go to whichever quadrant I need to find the answer. So we're going to do the check it out together because I think it does do, yep, it involves a negative. And we will talk about this two ways just for the sake of doing it because when we do inverses, it works correctly anyways. But okay, so we're going to do, so we'll do the inverse tangent of positive 2 first of all, because I want a reference angle from the first quadrant. And then I'll look at, okay, where is tangent negative? And I'll go from there to find the specific values I'm looking for. And we're actually going to do this two ways just because to show you something else too. All right. So what do I get when I do the inverse tangent of 2? Okay, 63.4 degrees. So that means then that if I draw, now let me go a little extreme. Oops. So that means that this angle here is 63.4 in all 3 quadrants. Okay? Or all 4 quadrants. Now it just depends on which one they're talking about. So they have the tangent of theta equals negative 2. Well, where is tangent negative at? No. It's negative when y over x is negative, right? So when sine and cosine have opposite signs, or y and x have opposite signs, it's negative. So we're talking about up here in the second quadrant, because sine is negative, cosine is positive, and down here in the fourth quadrant, where sine is negative and cosine is positive. So for letter A, the restriction is between negative 90 and 90. So if we're in the fourth quadrant then, okay, so we're talking about the first and the fourth quadrant, we go from negative 90 to 90, then that means that my angle then for letter A, theta will be equal to negative 63.4. Because I'm just going to use the negative of the angle, not subtract it from 360, because it says between negative 90 and 90. But take your calculator, and if you actually do inverse tangent of negative 2, it'll give you that. Okay? Because the calculator does know, right, when we talked about inverse sine and inverse tangent, that If it does it for a negative, it's going to give me a number between negative 90 and 90 because that's part of their restrictions, okay, that we talked about with the inverse functions. So then for B, it says between 90 and 180, so it's in the second quadrant. So in the second quadrant, to get the angle, I have to subtract it from 180 degrees. So some people try to work with the 90, and that's the nice thing about the reference angles is we know everything works off the horizontal. So you have to work from the horizontal to find those things. So when you're doing these types of problems then, all right, we're trying to find the reference angle, and then which quadrants am I going to go to with that reference angle? Is it the first, second, third, or fourth? And do those things with it. Okay. Does that make sense? A little bit?